we start by revising this particular topic. I'm going to start with SURDS. Okay, so I'm going to start with SURDS. Make sure that you are writing something. So when you look at a SURD, okay, when you look at a SURD, we are simply talking about certain numbers that are expressed with a root or a square root, but in the actual sense, they cannot be expressed in the form a over b. These are numbers that are irrational. So a SURD is simply an irrational number, okay, in general, and it cannot be expressed in the form a over b, okay. So in general, a SURD is an irrational number it is an irrational number and it cannot be expressed in the form a over b. It cannot be expressed in the form a over b. You cannot express a SURD in that particular form. This implies that for every SURD, for every question that you are going to be given under SURDS, and it is in the form a over b, ensure that the denominator does not have a square root. Ensure that the denominator does not have a square root. Examples of SURDS. Very good examples of SURDS. We can have the square root of 2 is a SURD. Square root of 2 plus 1, this is also SURDS. If you have root of 2 plus root of 3, this is also a SURD. Okay. If you are going to have something like 2 root 3, this is also a SURD. If you are going to have 2 root 3 plus 7, this is also a very good example of a SURD. So these figures, these numbers that I have put there, there is a way in which we operate them. And they've got a special way in which you are going to be operating them, and you need to know the concepts of operation. There are certain rules that you are going to abide to. These are the rules of SURDS. You do not disobey these rules. The moment you disobey any of the rules, that is the failure of your answering of that particular question. What are those rules? The first rule that I'm going to introduce to you is called the product rule. Product rule implies that I am multiplying these guys. Now, how do you multiply SURDS? The first example I'm going to give is this one. If you've got the square root of a, and then you are multiplying square root of a with the square root of b, what you are going to do is to combine the two and multiply them. So it will be a times b. Hello? That is one rule you should understand. That is one rule you should understand. That is one rule I want you to understand. Square root of A multiplied by square root of B okay, so that is the thing. So what does this mean? Okay, someone wants to join. What does this mean? This means that if I have the square root of 2 and I'm multiplying it by the square root of 3, this is the same as the square root of 2 multiplied by 3, and I'm going to get a root of 6. Please understand what I have done. This is called the product rule. This is called the product rule. Another one which I want you to take note is, how about if you are multiplying the square root of the same bases, the square root of the same numbers? For example, this time around we've got A multiplying with the square root of A. What answer are you going to find? The answer which you are going to find, it's very simple. Cancel the square roots. The square root cancels each other if what you're multiplying is the same. And what you're going to get is A. Can I make a practice example? If you have the square root of 2 multiplying by the square root of 2, your answer is not 4 but 2. These are rules of SURDS, and I want you to understand them so much. These are rules of SURDS, and I want you to understand them very well. Okay? The moment you understand this, you are going to enjoy this simple topic very much. You're going to enjoy it so very much. Okay? So, having done that one, let's now try to do something. Let's try to do another rule. The second rule is going to be called the sum rule. Let me call it the sum rule. It is called the sum rule. Sum rule implies you are adding the figures. Now, if you've got, for example, C root A plus let's say you've got D root A. Someone wants to join. So, you've got C root A adding to B root A. Notice what... Okay, someone wants to join. Notice what is going to happen. Notice what is going to happen. What is inside is the same as this one. So, you treat them like terms. You treat them like terms. Just like 2x plus 4x is equal to 6x. So you are adding the coefficients and you have 6x. That's what you do here. So if you're having the same bases, A and A or B and B, your addition will be C plus B, the square root of, then you maintain A. Okay? So if it is a practice question, for example, if you've got 2 square root of 4 plus 3 square root of 4, you are going to add these guys. So this will be 5 the square root of 4. Did you see me do this? Did you see me do this? Have I done this? This is wrong. This is right. Make sure that you understand what I am doing here. The third rule I want you to understand is called the quotient rule. It is called the quotient rule. Make sure you have a pen and a paper and you're writing. The quotient rule. What does quotient rule mean or imply? The quotient rule, if you've got, for example, the square root of A, okay, then you are dividing it by the square root of B. How do you write it? This is just the same as the square root of A divided by the square root of B. Now, if you are using SURDS, you can maintain the square root and just divide them like that. That is very important for you to understand. Just from these rules, we are able to solve as many questions as we can. Let's try to do some practice questions. Suppose a question came. They ask you, say, 2 root 4 plus 3 root of 4. You are going to use the sum rule. Just add what is here and what is here and maintain the base. So that is going to become 5 square root of 4. How about if you have 3 root of 2? How about if you have square root of 2 plus 4, sorry, not plus, let me put a minus, root of 2. So this is just the same as 3 minus 4, negative 1, root of 2. So this becomes negative root 2. How about, for example, if you have been given this, root of 2 plus 3 root 2. There's a 1 here which you can't see. So you say 1 plus 3, it gives you 4 root 2. Okay, that is very important for you to understand. D. How about, for example, if you have been given square root of 3 plus, sorry, square root of 3 divided by, okay, let me put square root of 9 divided by square root of 3. This can also be written as square root of 9 over square root of 3, which can also be written as everything 9 over 3, and that becomes a root of 3. That is called the quotient rule. How about, for example, if you have 2 root 2 multiplying by 2 root 2. This is just the same as 2, okay? That 2 which is here is going to multiply with the one which is here. Then, hello, your microphone is on. Please mute yourself. Gift Mulenga, mute yourself. How about if you have this? So these 2 here, we will multiply with this one here. Please, if you get logged out, don't text me about the network. It will just confuse me. I'm recording the class. Immediately I'm done teaching, I'm going to post this lesson and you have it, those that paid. So watch the lesson before tomorrow morning, before they give you your quizzes. So this is just the same as root of 2 multiplying by root of 2. So here you are going to have root of 2, and make sure you attend this one. Okay, even if I'm recording, attend this one, it will be helpful. What is square root of 2 multiplying by square root of 2? That and that cancels, and you're going to have 2. And your final answer becomes 4. So this is how these rules are going to help you. They will help us. Okay? These rules are going to help us a lot. So let's make sure that we understand how to use them. If you have a question, just unmute yourself. Don't raise your hand. I'm not able to see the other end. I'm only seeing the screen where I'm writing from.
Basa, where did the one go on B?
Because you're multiplying 1 multiplied by 2, it's giving you 2.
Okay, thank you. I understand. Negative square root of 2.
Where? For B?
Yes.
Which one? B or?
The B. The final answer, like I saw negative 1 to the square
What
root
is
of
3
2.
minus? What is 3 minus minus 4?
Negative 1.
So that's the negative 1. I just don't want to put negative 1 there. It won't look nice. So that's how you do that question.
Okay, thank you.
I'm sure everyone understands this part. I've done a lot of questions. For this. Now, let's go into.
I have a question first before you move on.
All right.
On C, how did those 2 square roots cancel themselves? Like,
Remember what I mentioned about the product rule? Can someone tell us what the product rule is? Product rule when you're multiplying same bases. Can someone unmute themselves and just talk? What did I say about the product rule?
You cancel the square root and maintain the same base.
Very good. You have a 2 in here and a 2 in here. When they are multiplying, root 2 multiplied by root 2, you just cancel the square roots. And you're going to remain with it. Sorry, this is not multiplication, it is addition. So, because it is addition, I said they are just like terms. So, this is just the same as 1 plus 3. you add the coefficients, like the same way 2x plus 4x gives you 6x. So this is it, 2 root 2. Please don't miss anything, and don't lose me. The one who asked, is it clear?
Yeah, oh no, I meant on E, not C. Like here, when you did the multiplication to say 1 times 2 is 2. Now here, these two square roots.
That's what we are saying. What is the product rule? That's what your friend said. Your friend said that when you are multiplying the same bases, when you're multiplying two square roots having the same bases, just cancel the square roots.
All right, I got it.
All right, thank you. We can go to the other questions. We see how well we are going to simplify this work. Don't miss me, and make sure you apply, because I'm very slow when teaching, so that you understand. The first question is saying, simplify the following sets. A square root of 50. B square root of 72. C square root of 147. D square root of 48. E square root of 12. Solution. If you are to start with the first one, let me make mention. Whenever you are dealing with the SURDS and you have been given a square root, you have been asked to simplify. What is important is always start by inserting a small number into what is inside. By a small number, I mean you are going to start with so let's do testing numbers. Your testing numbers, you start with 2. From 2, if 2 does not work, go to 3. If 3 does not work, go to 4. How do you use these testing numbers? These testing numbers, you ask yourself, can 2 go into 50? Can 2 go into 50? Yes, 2 can go into 50. If 2 cannot go into 50, don't use 2. Use 3. If 3 cannot go into 50, don't use 3. Use 4. Okay? So in this case, I'll ask myself, which number can go into 50 amongst my test? You remember I said you can use any, provided you started from 2. They can keep on going like that. Now, can 2 go into 50? Yes. 2 is capable of going into 50. How many times? 25 times. So, if 2 can go into 50, if 2 can go into 50 and it's giving you 25, then it means that 2 multiplied by 25 gives you what? 50. So now, ushe fiara kwa fuilishe nshi ukwishiba the number which you are going to put muri 50. How is it going to help you? It is going to help you because you be able to break down the 50. The key is to break down what is inside. So let's break down what is inside. Can 2 go into 50? Yes. How many times? Okay, 2 is able to go there. The answer, when you insert 2 into 50, then 25. So it implies that this can also be written as 2 multiplied by 25. Guys, is this true or it's a lie?
It's true.
Thank you. Thank you. It's true. So, if that is true, then you can break them down. You can break them down. Please, I said you can break them down. Don't ask me to say, why are you breaking them down? You are supposed to break them down. Okay? Because this is mathematics. So you can say square root of 2 multiplied by square root of 25. This is still the same thing. This is still the same thing. Okay? So this can also be written as 25 multiplied by, what is the square root of 25? 5. Your final answer is going to be written as 5 square root of 2. That is the simplified form. We go to B. We have the square root of 72. You ask yourself, test the numbers. Can 2 go into 72? Let's try. 2 into 7 is going there 3 times. Remaining what? 1. Okay? So, can 2 go into 12? Yes. How many times? 6 times. So, meaning 2 into 72 is 36. So, let's try to see if it works. So, we have 36, then 2 here. We multiply. 2 into 2 multiplied by that, it is 12, carry 1. 2 multiplied, it is 6, so it is true. Okay? This implies that 2 multiplied by 36 is given as 72. So we can break down this guy here. So this can also be written as 2 multiplied by 36. So that can also be written as square root of 2 multiplied by square root of 36. Square root of 2 multiplied by, what is the square root of this guy? 6. Henceforth, your answer is 6 root 2. We go to C. C, you have the square root of 147. Can 2 go into 147? Let's say 2 into 14, it is 7. 2 into 7, it can't go there. So we can't use 2. Let's try 3. 3 into 14, it's going there how many times? 4. Remainder 2, because it's going in 12. So remainder 2. The 2 is put here. It becomes 27. 3 into 27, it becomes 9. So we are getting 49. Let's prove. 49 multiplied by 3, it should give us 147. 3 multiplied by 9, we are getting 27. So 7 carry 2. 3 multiplied by 4, we are getting 12. Plus 2 becomes 147. So this can also be written as 3 multiplied by 49. Square root of 3, when we break it down, it will be square root of 3 multiplied by 49. Henceforth, square root of 3 is going to multiply. What is the square root of 49? 7. So we're going to have 7 root 3. Any question up to this level? Thumbs up if it's clear. Give me hands, thumbs up. right, thank you. It's clear. All right, thank you. Thank you so much. Let me do for 12. It's just one and the same thing. How many times can 2 go into 12? Oh, it's 6. So this can also be written as so, very good, very good, very good. Notice, I tried 2. 2 can go into 12, right? Yes. So 2 multiplied by 6 is giving me what? 12. But look, when I divide the 2, is it making sense here? No, it's not. It's not making sense at all, because you can't find the square root of 6 and the square root of 4. So whenever you find something like this, know that what you're doing is wrong. Know that what you're doing is wrong. But because you are my student and you learned from me, what are you going to do? Because you are clever, you know that actually 4 multiplied by 3 is 12. And this can be broken as the square root of 3 multiplied by square root of 4. So you know that square root of 4 is a 2, and square root of 3 doesn't exist, and that becomes your simplified form for this guy here. Okay, we can go on to some other things. I'm sure you are copying what I was writing. Let's try to do some other things. 2. Simplify the following operations. The first one is square root of 18 plus square root of 8. B 5 root 3 minus 2 root 12. C 2 root 5 plus 3 root 20. D 7 root 2 minus 4 root, okay, this is root 50. How do you perform these operations? How do you perform these operations? To perform these operations, let's start with the first one. We have the square root of 18 plus the square root of 8. Different bases, we can't even add them. But there is a way in which we can simplify them. Let's work out this part the same way we're doing here. We know that a 2 can go into 18. And it's going there 9 times. And we know that 9 is easily square rooted. So it gives us a very good at least area where we can do something. At least it's cool. This entails us that the square root of 18 can also be written as 2 multiplied by 9 plus 80 divided by 2 gives us a 4. And we're able to find the square root of a 4 the easy way. This entails that this can also be written as a 2 multiplied by 4. We can break down these guys. We can have square root of 2 multiplied by square root of 9 plus square root of 2 multiplied by the square root of 4. Then we know that this is a 3, so it will be 3 root of 2 plus this, we know that this is a 2, so it becomes 2 root of 2. From summation rule or the sum rule, because you have the same bases, you just add the coefficients. 3 plus 2 becomes, from this rule, which rule is that? From this rule here, this one, the sum rule, we can add 3 plus 2, we maintain the base. That becomes a 5 square root of 2. That is how you simplify such questions. Someone wants to join? We go to the second one. 5 root of 3 minus 2 root of 12. Notice that the bases are different. We can subtract. But there is a way in which we can make them easier. Now, look at these guys. Look at this. This guy is a square root of 3. We can't go any further. We can't find the square root of 3. But we are able to manipulate this guy. We know that square root of 12, I showed you, it is the same as 4 multiplied by 3. It's going to give you 12. So the square root of 3 can be subtracted from some 2, where we can break down the square root of 12 into 4 multiplied by 3. It is very true if we write it this way. Henceforth, the square root of 3 can be subtracted from 2. Then we can have square root of 3 multiplied by square root of 4. Then we are going to have 5 square root of 3 minus, then we are going to have a 2 here when we find the square root of 4. Then this same 2 multiplied by this 2. Okay? So we're going to have 5 root 3 minus 4 root 3. Now look at what I've done here. The bases are the same. But I've got a minus here. So if the bases are the same, you subtract the coefficients. 5 minus 4 gives us 1. So we can't write 1 root 3. It's just root 3. That's how you find these questions. Thumbs up, thumbs up, thumbs up if you are getting it. Thumbs up if you are getting it. Thumbs up if it's clear. Thumbs up if it's clear. All right, thank you. If you have a question, please just ask.
I'm a bit behind.
Huh? What are you saying?
Like I'm a bit behind
Where are you behind?
this same second question.
Yes, where are you
This same
behind?
second question.
Yes, tell us where you are behind on this on the same question.
Here you introduced us for 12. What are you seeing? Somewhere here.
Yes, how do you break down the square root of 12 when you're using SURDS?
Which we can apply.
I said square root of 12 can also be written as 4 multiplied by 3. It's just one and the same thing. Then you break them down the same way we have been doing the others. This becomes 2 root 3. Hello?
Hello?
Is it clear?
Yes.
Okay. Please, we don't want to lose anyone in this session. Remember, you paid for it. Let's try to do C. Let's try to do C. If I'm doing C, square root of 5 plus 3 root 20, we can't do anything about 5 because it has reached its end stage. We can leave it like that. But we can do something about 20 because 20 can also be written as the secret about SURDS, guys. Always leave things in the way that you can simplify them using square roots. So here you can't say 2 multiplied by 10. What are you going to do with the 10? Can you find the square root of 10? I'm the I'm sure I'm the only one who can find the square root of 10 here. Can I find the square root of 10?
Yes.
I show you without using a
Yes,
calculator.
show us.
So if you want to find the square root of 10, okay, you want to find the square root of 10. What you do is, you can also write it as 1, the square root of 1, okay? You say the square root of 1 plus the square root of 9. So you know that the square root of 1 is 1. So you say square root of 9 plus 1 over 2 multiplied by 5. So this is going to become 3 plus 1 over 2 multiplied by 5 becomes 10. So this becomes 3 plus 0.1. So the square root of 10 is 3.01. Okay, so sorry, 3.1. What are you getting? What are you getting? Hello, what are you getting? You can punch it on your calculator directly. What are you getting? Students, are we together? What are you getting when you find the square root of 10?
3.16.
3.16. So you've agreed that that is correct, right? If you want, you can even find the square root of 13. I show you.
Yes, sure.
Square root of 13. So this can also be written as square root of 12 plus square root of 1. So this is 12 plus 1 over 2 multiplied by 5. Then you do the same thing. Square root of 11. This will be 1 over 2 multiplied by 5 plus 1 over 2 multiplied by 5. Then you do the same. Square root of 10. This will be 1 over 2 multiplied by 5 plus 1 over 2 multiplied by 5 plus 1 over 2 multiplied by 5. Then you say square root of 9. This will be plus 1 multiplied by 2 multiplied by 5 plus 1 over 2 multiplied by 5 plus 1 over 2 multiplied by 5 plus 1 over 2 multiplied by 5. So we're going to have square root of 9 is becoming 3 plus this is 0.1 plus this is 0.1 plus that is 0, this is 0.1 plus this is 0.1 plus, so this becomes 3 plus 1, 2, 3, 4, 0.4. So that becomes 3.4. What is the square root of 13? People are not talking.
It's given me 3.6.
3.6. Another person, what are you getting? Square root of 4. Square root of 13.
Uh, 3.6.
So it is just in the same range. It is just in the same range, you see? So 3.4, 3.6, 3.5. That's how you find the square root without a calculator, okay? Anyway, this is not what I came to.
Sir, try to repeat.
No. This is not what I came to teach. These are my own mathematical tactics. I'm the only person who can find square root of numbers without calculator. Okay, we don't need a calculator here. Can find anything. Okay. So look at this. It was 20. But you can't break it down in this way because you can't find the square root of 10. You'll be stuck. You'll be stuck when you write it this way. You'll be stuck, very stuck. So don't put it that way. Instead, what are you going to do? You are going to say 3, then you say 4 multiplied by 5. Okay? Because in your testings, when you put 2, yes, it will give you 10, but 10 can't find a square root. If you use 3, it won't give you a number. It will give you a point something. If you use 4, it's giving you what? 5, but 4 you can find the square root of 4. So make sure you are clever enough to find these questions. So this becomes 2 root 5 minus 3 square root of 5 multiplied by the square root of 4. Then you have 2 root 5 minus, this is going to be, this is a 2. That guy multiplied by that 3 becomes a 6. Have you seen the bases? They are the same. What is 6 minus 2? So this is the same as 2 minus 6 square root of 5. That becomes negative 4 square root of 5. Thumbs up if you are clear. Thumbs up.
I'm behind. Where is that negative coming from?
Okay, you are going to understand later. You are going to understand later. 2 minus
Yeah.
6.
So for me, like I can't see anything. I can only see like your profile, which is just slim, and like I can't see anything. So I'm really behind.
The thing is being recorded, Mama. You have access to it. Even if you ask a question, even if I repeat, it won't work.
Oh, okay, sir. Thank you very much.
You are going to have access to the recorded video, okay?
Okay.
You are very special, okay?
But I also have the same question. Now we have plus 3, then all of a sudden it's negative 3.
What? I didn't
On
get
the same C that you're answering, from what we had was 2 to the square root of 5 plus 3 to the square root of 20. Then when you started answering, you've written 2 the square root of 5 minus 3 the square root of 4 times 5.
What does that
Yes,
part?
I'm saying I
also had the same question of how it has changed from positive to a negative.
Oh, it's a positive here, right? So this becomes 8. Thank you so much for the correction. Thank you so much for the correction. This becomes 8. So that becomes 8 root 5. Thumbs up if we are clear, we move on. I'm sure people are understanding the concepts. I like the energy. The last question you're going to do. Should we also do it? D. Should we do D also?
Yes.
Should we do D?
I think in the concepts, if at all it's we can go and show you our solutions. We can go to the next one.
Let me just solve to avoid problems.
No, let us change.
Let's solve to avoid problems. We have D. 7 root 2 minus 4 root 50. I'll be very quick. Because you can't do anything about it. It is even giving you a picture that your base is going to be a 2. So this can also be written as the root 2 minus 4. I won't waste time here. I know everyone knows it is 2 multiplied by 25. 7 root 2 minus 4. Even here we won't waste time because we know that we can separate these two. 7 root 2. This becomes square root of 2 multiplied by 5. 7 root 2. This becomes 5 multiplied by 4. It becomes negative 20. Square root of 2. Then we can subtract. What is 20 minus 7? It's giving me negative 13. Root 2. Okay, thumbs up if you are clear. Nancy, if you want to ask a question, you unmute yourself. Thumbs up if we are clear. Thumbs up. Thank you. Thank you so much. We go to another part. Section 3. We are going to be rationalizing the denominator. Before we go to rationalizing the denominator, I want to show you something, guys. How do you find this? Suppose you have got the square root of 2 plus the square root of 3, then they say everything to the power 2. How do you find that one? I want you to pay attention because most of you, when you're doing when you're trying to prove irrational numbers, you find challenges multiplying this. This can also be written as root 2 plus root 3, then multiplying by itself. Pay attention to what I'm going to be doing here. Root 2 multiplied by root 2 gives you what? Can someone unmute themselves and answer? What is the root 2 multiplied by root 2?
2.
Very good.
2.
Very good. It is 2 plus. What is root 2 multiplied by root 3? It is 2 root multiplied by root 3. We go to this guy. What is root 3 multiplied by root 2? It is root 2 multiplied by root 3. Plus, what is root 3 multiplied by root 3? Quickly.
3.
3. This part, you're using product rule. So they can also be written as 2 plus 2 multiplied by 3 plus square root of 2 multiplied by 3 plus 3. So this becomes 2 plus root of 6 plus root of 6 plus 3. What is root of 6 plus root of 6?
6.
6.
What is root of 6 plus root of 6?
6. Root of 6.
No. What is root of 6 plus root of 6? What is root of 6?
Root of 6.
No. Guys, give me answers. What is root of 6 plus root of 6? Guys, summation rule, guys. Sum rule.
Two root of 6.
There's one there, there's one there. It is 2 root 6. So, this can also be written as 2 root 6 plus 3. 3 plus 2, it is 5 plus 2 root 6. That's how you find this. Thumbs up if it's clear. All right, thank you. Let me I just wanted to clear that one just for the sake of revision. For the sake of revision, we just wanted to. Okay, so right now we need to work with the denominator. Rationalizing the denominator, I'm going to show you what they mean. Pay attention here, this is where questions will come from. That's where questions come from mostly. To rationalize the denominator, it is actually very simple. The only thing that I want you to do when I give you a question, I ask you to rationalize the denominator. The only thing that I want you to do when I ask you to rationalize the denominator, I want you to remove the square root from off the denominator. Remove the square root from off the denominator. Remove the square root from off the denominator. How do you remove the square root? You are going to introduce this same guy here. You introduce him there. Because I know that the square root of 3 divided by the square root of 3, please forget about that rule. This is just same as 1. This is just 1. It is just the same as 1, 1. 1 into 1, it is 1. 1 multiplied by 1 over the root of 3, it is the root of 3. So when you introduce that, it's same as you have done nothing. It won't affect. So that's what you do. You introduce the square root. Then you will see how it's going to come out from there. What is 1 multiplied by root of 3? It becomes the root of 3. over. Root of 3 multiplied by root of 3 becomes 3. You have rationalized. You have removed the denominator, the square root from the denominator. Thumbs up if it's clear. It's actually very simple. Let's try to do the second one. You can also do it on your paper. Quickly do it on your paper right now. Tell me what you're going to find. What have you found? Who has found the root of 12 over 6? Who has found the root of 12 over 6?
Papa screen parece APC.
It means your network is bad, so it's not picking up the screen. So what you do, you log out, then you log in.
Oh, okay. We'll try that. Yeah, there's no network.
Who has found my answer? Root of 12 over 6. No one has found that one.
I can give it a try, sir.
Okay. So now, from here...
There's a 5 on it.
Huh?
I can say the
Okay, mute
Yeah, I
yourselves.
can see it.
Let me just continue quickly. We finish the class so that we move fast. If I wanted to go deeper, I can say this can also be written as 4 multiplied by 3 over 6, then square root of 4 multiplied by root of 3 over 6. That becomes 2 root 3 over 6. That cancels. That becomes root of 3 over 3. I can go deeper.
The question before you go deeper.
Yes.
Where did you take the 5 on top?
The 5, let me see.
Where did the 2 come from?
Wait a minute, let me see what I'm doing here. Here's supposed to be root 5, right?
Supposed to be 5.
Okay, let's see. You see the problem of multitasking. I'm multitasking here. I need to be responding to the people. I need to be checking up if you are connected there. Okay. So this becomes, root what? 12 over 12, right? Okay,
Yes.
correct. Let's try to do C. 7 over the root of 5 minus 2. On this one, pay attention. On this one, pay attention. On this one, pay attention. When you have a minus, when you have something like this, you have a minus. Hello? When you have a minus, or you have a positive, or you have a plus, I don't know whichever you call it. When multiplying this side, change the sign. Change the sign. Change the sign. Change the sign. Square root of 5, because there was a minus there, I'll say plus 2 over square root of 5 minus 2. Square root of 5 multiplied by square root of 5 gives me 5. Square root of 5 multiplied by negative 2 gives me negative 2 square root of 5. Sorry. Square root of 5 multiplied by positive 2 gives me positive 2 root 5. Negative 2 multiplied by positive root 5 gives me negative 2 root 5. I'm multiplying the base, please, first of all, the denominator. That's why it is important. The negative 2 multiplied by positive 2 gives me negative 4. Then we know that 7 multiplying this whole thing here is just the same as that is just the same as 7 root 5 plus 7 multiplied by 2, it is a 14, all over by, this is a 0 because they are cancelling each other. So we're going to have 5 minus 4. It's going to give us a 1 there. Have you seen that I've rationalized? That becomes 7 root 5 plus 14. That's how you solve that one.
Maputa.
Okay, I'm sure you've copied.
Sir,
Yes.
I'm kind of confused here. I thought at first you said 5 square root plus 2 over 5 square root minus 2.
I don't understand what you're saying. I don't understand what you're saying.
I'm saying here where you've written 5 plus 2 on top, even 5 plus 2 on top over 5 plus 2. I thought at first you said the papa school week up or minus.
No. I look, I was demonstrating here that this, when you cancel it, it should give you 1. If I put a minus 2 there, when you cancel it, it will give you 1.
No.
Eh. Okay, we proceed. Is it clear? That one was talking. Is it clear?
Yes, sir.
Okay, let me do this last one. Try it out. Try it out. Just a quick one. You can try it out. A quick one. Try to solve it. Ish. Huh. You guys are causing my phone to hit. Honya ndingaiporeke. Try. Try. Have we done it? Okay, let's solve the question. Let's solve the question. The question is saying 1 over the root of... now, okay, for this one, we shall do the same thing, eh? Okay, square root of 3. So, you can do your calculations from there. I've changed the sign. So 1 multiplied by the things on top, it becomes root 5 minus root 3 over, remember how we multiplied, so square root of 5 multiplied by root of 5 becomes 5. Root of 5 multiplied by negative root of 3 becomes minus 5 multiplied by 3. Then positive may not bring problems. Let me just wrap that. Positive root 3 multiplied by 5 becomes positive 3 multiplied by 5 inside. Then positive root 3 multiplied by negative root 3 becomes negative 3. This is a 0, we all know that. So we are going to have root of 5 minus root of 3 over 5. 5 minus 3. So root of 5 minus root of 3 will give us that. Okay, thumbs up if it's clear, guys. Quickly. I'm sure it's clear. I'm sure it's very clear. I think I've taught this topic. I've taught this topic. You go in your tutorial sheet and you can solve the rest. Clear about this topic? Clear? Thumbs up. You can do anything now. You can do anything now. Alright, thank you. Let's try to introduce the operations. So what I'm going to do is I'm going to teach binary operations in such a way that at least you'll be able to solve important questions that can be brought to you by your tutors. Okay? Important questions that can be brought to you by your tutors. Hello?
Question before we proceed.
Yes.
So is this all we can expect on SURDS?
You can go, you can check as many questions as you can. It's one and the same thing.
There won't be too much of a difference.
Why?
I'm just asking if they are more complicated SURDS.
No. There might be complicated SURDS, but you use the same concepts.
Okay, thanks.
The topic is very simple, guys. When I teach. Okay? It's very simple when we teach. So, go in your tutorial sheets, solve those questions if they're there. Mostly, SURDS are helpful. Knowing SURDS are very helpful when you're doing rational and irrational. But they might give you a question there. Okay, we proceed. I know the reason why he's asking that question. The topic looks very simple. It's simple because I've taught. You can get the same questions and give your friends. You're going to see drama. Okay, new topic. Binary operations. So, what is a binary operation? A binary operation is an operation that combines two elements from a given set It is an operation that combines two elements from a set to give another element. To give another element from the same set. A binary operation is an operation that combines two elements from a set to give another element from the same set. In other words, if you have a set of real numbers, if at all you create an operation between two elements from that set of all real numbers, what you should produce should be a member of all real numbers. If you get two students from set A, you make an operation amongst the two students. What you must produce is a student and he should be a member of the set where you got those two from the beginning. So, in general, or in its simplification, I can say it's just a rule. It's a rule that takes two inputs and gives one output. You get two inputs and produce one output. Let's look at the formal definition. What is the formal definition of a binary operation? If at all, for example, you get two elements, this S and that S, two elements from all real numbers, you should produce an output which is going to be an S, and that S should be a member of all real numbers if we are dealing with real numbers. If we are dealing with integers, a set of integers, it should be S should be a set of integers, okay? Or you can call positive integers. If it was a set of natural numbers, S should be a member of natural numbers. Let me give an example. Okay, let's say we are dealing with integers. Okay, let's say we are dealing with integers, right? If you are, if at all you are using, let's say, this is a set of integers, let's say of A, B, C. If you make an operation, between A and B, okay, you say A star B, you should produce at least an element. It can be C. It can be C, it can be anything. Okay? And this C should be a member of, remember we said that these are integers, should be a member of positive integers. This, please, this concept works when we are dealing with addition and also multiplication. Mostly addition and multiplication, they survive in a binary operation. They give, okay, they give a proper binary operation, a possible binary operation. But in most cases, division doesn't. Take note, addition does, multiplication does, but in most cases, division doesn't. Now, I want to look at certain properties, I'll say important. Important properties. Binary operations. The first property is called the commutative property. Commutative law. Commutative law simply states that if you've got the binary operation A star B, by the way, this star means operation. Guys, this topic is found in computer science. This is what computers use. When you enter two numbers, the computer calculates by itself. Shani, it's binary operations computers use. So, if you've got A star B, this can also be written as B star A. If this agrees, then you are telling me that this is what you call the commutative law. Then it means the operation on star is commutative. If that agrees, the operation on star is commutative. We go to B, to the second question. The second row. Before I even go any further, let me try to go a little bit deep on this particular part. This implies that if we let A be equal to 1 and B equal to 2, then we want to operate this operation. If we're using addition, let's try addition, then we can say that A plus, so in this case, our star or operation is an addition. If we say A plus B is equal to B plus A, so we can say, let's try it to see if it works. A is 1 plus 2 equal to B is 2 plus 1. So here we are getting a 3, here we are getting a 3. And telling you that the arrangement or order is not important. So what does this entail you? It entails you that the operation on star is commutative. Yes. But if this wasn't agreeing, then you say the operation on star is not commutative. We go to the second law. The second law is called the associative law. The associative law states that if, for example, you've got A star B star C, this can also be written as A star B star C. This is associative. So, if, for example, A is equal to 2, B is equal to 3, C is equal to 4, if we are using multiplication, then we are going to say that A times B times C is equal to A times B times C. We see if it works. Where there is A, I can put 2, then multiplied by 3, multiplied by 4. Where there is A, I can put 2, multiplied by 3, multiplied by C. This can become 2 multiplied by 3 is 6, multiplied by 4 becomes 24. The other end is 2 multiplied by 3 multiplied by 4, that becomes 24. So they both hold. So if this is true, we can say that the operation on star is associative. The third law is distributive. Distributive law. Ish. That's not how we write the word distributive. So distributive law simply states that if you are having A star then B star C, this can also be written as A star B, then whatever operation you'll be dealing with, then B star C. Sorry, then the same A star C. In other words, this one works properly when you're doing multiplication. So if you're multiplying A multiplied by B, then this is going to be plus C. This can also be written as A multiplied by that B. Then this plus, you put it, this plus is this guy here. Then you say this same A multiplied by C. That is what the distributive law simply states. Don't get tired. I know we've been learning for some time. Don't get tired. These lessons are very, very long. Let's try to see how these things are going to work. We're about to end. Let's try to see how these things are going to work. Guys, if you are given, let's say an example. If you are given a question, then it's saying let a binary operation star be defined on integers. So what do you with integers? Okay, let a binary operation star b defined on integers by, then they say a star b is equal to a plus b plus c. Sorry, plus 1. I want to explain something here. If you miss this part, then I don't know. Plus 1. Then the question says, determine the following. A, commutative. B, associative. C, distributive. Solution. Guys, here what they're telling you is this. You let a binary operation star be defined on integers by this particular equation. What a star b equal to a plus b plus 1 simply tells us that the operation that you are dealing with is a plus. Then every time, okay, every time you are going to be performing this operation, please understand this part. Every time you are going to be performing this operation, every time you perform an operation by star, you are going to be adding 1. Okay? Every time you perform an operation by star, you'll be adding 1. So in this case, according to the equation, a star b, if we're using addition, it's just the same as a plus b. But this time around, they have added 1. This tells you that accordingly to the way they set the computer or the operation, every time you perform star, you are supposed to add 1 to anything that you are going to perform. So in this case, if at all maybe we performed an operation of b star c, it means that this can also be written as b plus c plus 1. Hello? That's what that implies. Every time you perform an operation, you'll be adding 1. So in this case, we want to prove commutative. Commutative law simply states that A star B can also be written as B star A. So now let's try it. We see if it's going to work. So notice that A star B, according to the question, was given to be A plus B plus 1. Okay? That is what they said, accordingly to them. So now let's try to see what B star A is going to imply, okay, for this particular question. This implies that if A star B is equal to this, then B star A is going to be, the B is going to move from here to come here, the A will come here. So we say this can also be written as B plus A plus 1. Then we test. We can say let A equal to 1. You can use anything. B equal to 2. So notice we said that A star B is equal to B star A, and that is commutative. So where there is A star B, we can put its equation. where there is B star A, we can put its equation. Then we can put 1 there plus 2 there plus 1 equal to, even there you can put your 2, you can put your 1, you can put your 1. This becomes 3 plus 1 becomes 4. This is 1 plus 1 becomes 2 there. 2 plus 2 becomes 4. Because you are finding the same thing, you can conclude that the operation star is commutative. Now let's try to prove associative. This is why I want you to pay attention. Let's try to prove associative. You can write down there. Okay, let me work it out. Associative simply states that if you have A star B star C, that can also be written as A star then B star C. That's what we said. That is what we said. Now, according to the question, they are saying A star B is equal to, according to the operation, it is equal to A plus B plus 1. The key is to prove that what is there and what is on the right, left, it is just the same. Or if you change them, the way this, if you are to do an operation on the left hand side, you also do an operation on the right hand side, you should be getting the same thing, the same thing, the same thing, and the same thing. That's the whole essence of binary operations. They are very simple actually. So if you are to perform the associative law, how is it going to be? It will be very simple actually. Look, A star B is A plus B plus 1. So we can choose first of all operate this guy. So we're going to say A star B star C. Okay, how can we also write it? Where there is this part here, where there is this part here in the brackets, I'm going to replace. So I'm going to replace with this guy. Okay, if I want, I can say, okay, to make it easy, let me use this concept to make it easy. Guys, if I want, I can say, let A star B equal to Z. Please pay attention. Let A star B equal to Z. To make it simple, then this is going to be Z star C. Z star C. Now, this is associative, please. This is associative. Pay attention. This is going to be Z star C. Now, remember what I said. Accordingly to the operation, accordingly to this computer we are dealing with, accordingly to this computer, I'll be very slow, please. Accordingly to this computer, every time you are going to perform an operation star, whatever you are going to have, add the one. That's what this means. So, in that case, we've got Z star C. This implies that Z star C can also be written as, since we're using addition, it can also be written as Z plus C, but since we're operating and we're doing an operation star, our command says we add 1. Every time you do an operation, you add 1. Okay? So, if you reach there, you can therefore say, where there is Z, you can put your operation. So, we can therefore say, I can put my operation where there is Z. So that is going to be A star B plus C plus 1. Then I know that A star B is this guy. So I can put my A plus B plus 1. Then plus C plus 1. This concept is what I'm calling as the Z concept. Always make sure that you equate something to Z associative to avoid confusion. Then this can also be written as A plus B plus C plus 1 plus C 1. So we're going to have A plus B plus C plus 2. So when we perform an operation A star B star C, this is what we're getting. Let's also try to do the same operation here. We see if it will be the same. A star B star C, we see if it will be the same as this part. We have an operation inside the brackets. We can say we let Z equal to B star C. Okay? Then that means that we are going to have A star Z. That is Z concept. Now, A star Z can also be written as A plus Z. Remember, according to the condition given in our operation, they are saying every time we perform star, for whichever we are doing, we should be adding 1. So, this can also be written as A plus Z plus 1. Okay? Then we can say that this is just the same as A plus, where there is Z, I can put my operation there. Okay? I can put my operation there, which is going to be B star C. Okay, B star C, then plus C, 1. Now notice that we have B star C there, right? B star C can also be written as because we are performing star again here. So this can also be written as B plus C. Yes, why a plus? Because we are adding according to the question. According to the question, our operation was positive, and I mentioned that. Okay, our operation is, our star is a plus. So this will be B plus C plus 1. So this can also be written as A plus, here I'll replace this, because B star C is the same as B plus C plus 1, because every time we perform star an operation, the condition says we add 1. Don't get confused. This is what you do in binary operations. And your final answer becomes A plus B plus C plus 2. Notice that what is here and what is here are the same. So, henceforth, the operation on star is associative. Okay, that is one thing that you must be able to understand for this particular question. I won't do distributive because mostly they won't ask you, they'll ask you commutative and associative. Okay, let me create more space. For now, let me just go directly to the question, to your question in your tutorial sheet. I think that is where they can get your question from your quiz. Let me just go directly. Then we can end it from there. We solve also one question, then we see how we're going to end it. We can end it from there. Do I have more examples? No. Let me do your question. Can we do the question in the tutorial sheet, then we wrap it there, we wrap it up from there?
Yes.
Okay,
Yes.
I'm sure you grab the concept. Though I'm going to do it for me. I'll use the same concept. This was question 22. It was saying the operation star on the set of real numbers R is defined by A star B okay, it's defined by A star B equal to, then we have A power 2 plus B power 2 minus 2. Then the question was saying, okay, so I've seen that it is different from your tutorial sheet. They changed the equation, but we can also practice also this one. It's very important for the sake of practice, where so they changed the equation, but every other thing was similar. I think I used the previous intake tutorial sheet. Okay, then the question was saying we determine whether it is commutative. We determine whether it is commutative. Then B, we also determine whether it is associative. Then C, the question was saying we determine whether we find 3 star 2 star 5. So when you look at this question, in this question we have this equation: A star B A squared, B squared. Alright, sorry. Okay, this was saying A to the power 2 plus B to the power 2 minus 2. Guys, I said for such type of questions, notice that every time you perform star on two elements A and B, your equation produces A to the power 2 plus B to the power 2. Then you are always subtracting a 2. You are always subtracting a 2. Okay? Every time you do this, you are always subtracting a 2. So what you are going to do, if you want to perform, if you want to check if it is commutative, you are going to say A star B is the same as B star A. Now, let's try to see the first one. So we have A star B. How can this also be written? So A star B is the same as A to the power 2 plus B to the power 2 minus 2. So B star A, you just exchange the positions, meaning your B will come here, your A comes here, then you have minus. Are these equations the same? Can someone answer me quickly?
Yes.
It means the operation on star is commutative. If you insert in, if you let A and B, C equal to that. And by the way, the first question was saying, is star a binary operation on real numbers? That's what it was saying. Is star a binary operation on real numbers? Do you know what you're going to do? When you prove this way, you can choose any of the equations. Okay, since they are the same, you can say A star B is equal to A power 2 plus B power 2 minus 2. Then you say, let me use my testing numbers. Let A be 1, B be 2. These are, remember what we mentioned in the tutorial. I said D, a binary operation is such that when you get the input from a certain set, two numbers from a certain set, they should give you one number which is going to be part of the set that you're dealing with. So if we are to check if star is a binary operation on real numbers, we are going to get two real numbers, and I got A equal to 1 and B equal to 2, and I can put them here and perform my operation. So this is 1. So if I perform my operation, this becomes A to the power, sorry, 1 to the power 2, 2 to the power 2 minus 2. So this becomes 1 plus 4 minus 2. This becomes 5 minus 2. That becomes 3. Is 3 not a real number? It is. So star, in this case, star is a binary operation on all real numbers. That's how you prove the first one. Okay? In your tutorial sheet, they said star is prove if star is an operation on all real numbers. That's what you do. So, yes, because we are finding 3 is a real number. So star is an operation on all numbers, At the same time, we have proven that this is commutative. Guys, is it clear now to prove commutativeness? Is it clear on how to prove commutativeness?
Yes. Yes.
Okay, maybe associative. That's why maybe let's wait. Okay, let me focus on associative. For associative, look what is going to happen. I said A star B star C is the same as A star B star C. That's what I said. This can also, we prove this part, we see what we're going to have. So if we're dealing with A star B star C, what concept are you going to establish? Z concept. Z concept. So if we are using Z concept, we can say let Z equal to A star B. Then this implies that we're going to have Z star C. Now, Moneni, upper we had A star B giving us A to the power 2 and B to the power 2. That implies that Z star C is the same as Z to the power 2 plus C to the power 2, and every time we perform star, we are getting a minus 2. Guys, is it the same? Yes. Okay, Z concept. So, if that is true, I can put my operation and put it there. So, therefore I can say this is going to be A star B to the power 2 plus C to the power 2 minus 2. Then while there is this guy here, I can put my equation. So this can also be written as A power 2 plus B power 2 minus 2 to the power 2 plus C to the power 2 minus 2. Okay, let me just wrap my board. I show you what is going to happen there. So, from here, we are going to have something like this. It will be A to the power 4 plus B to the power 4 minus 4 plus C to the power 2 minus 2. So this can also be written as A to the power 2, sorry, A to the power 4 plus 4 plus B to the power 4 minus, sorry, plus C to the power 2, then minus 6. So this that you get there is A star B star C. It is equal to A to the power 2, sorry, A to the power 4 plus B to the power 4 plus C to the power 2 minus B. Now let's try to prove if this other side is the same. So we want to prove if A star B star C is the same as that. What do? We can use the same Z concept where we can say we let B star C equal to Z. Then this is going to be A star Z. But look at the operation, what it is saying. Every time we perform star, we are getting, the time we perform star on A and B, we got A to the power 2 plus B to the power 2. So even here, it will be the same. Okay. So that's what it implies there. So from there, this is just the same as a to the power 2 plus z to the power 2. Okay. Then we can replace what there is a, what there is z, we can put our equation, our operation. That becomes a, so that becomes b star c. Okay, power 2. So b star c is the same as b plus c. Okay, b plus, look, we are having b star c, right? And I mentioned that every time we perform an operation, so this is the same as b to the power 2 plus c to the power 2 minus 2. We can put it here. Sorry guys, I don't know if I think my Airtel minute bundle's finished. Let me bring you back. Are you able to see me? Are you able to see?
Yes.
All right. So like I was saying, inside here, we are performing an operation, this one. So I said every time we are performing star, we introduce b to the power 2 plus c to the power 2 minus 2. That is what the equation is saying. So I'm going to replace it there. This becomes a to the power 2 plus b to the power 2 let me see. Okay, I forgot to put minus 2 this side. Why am I putting minus 2? It's because a slash z is the same as a to the power 2 plus z to the power 2 minus 2. That's what the equation is saying. I forgot to put a minus 2 here. So even here minus 2. That's the condition. Just obey the operation. So this will be the same as okay, so this is b to the power 2 to the power 2. That becomes b to the power 4 plus c to the power 4 minus 4 minus 2. That becomes a to the power 2 plus b to the power 4 plus c to the power 4 minus 6. Are they the same with the first one, with the first equation? Check. Your network is not good if you can't see the board. It's not me. Log out and log in. Guys, are they the same equations? Check. Are they the same equations? So this equation had a to the power 4 plus b to the power 4 plus c to the power 2 minus 6. That's what this part gave us. This part gave us, the other part gave us this one. Are they the same? No, they are not, because here there is a 2. So you can say therefore the operation on star is not associative. It's not associative. They are not giving the same. If you want to find, evaluate, we evaluate this part. To evaluate that part, you are simply getting this equation. You are getting this equation on the right hand side, this equation here. Okay, you get that equation that you made, then this part here is your A. This part here, okay, remember it's correlating with which one? Okay, okay, let me use another pen. I show you. Just see what it is correlating with. A is correlating with it. Sorry, let's use this one here for distributive. A is correlating with 3, so A becomes equal to 3. B is correlating with 2, so B is equal to 2. 5 is correlating with C, so 5 is equal to C. So in this equation, where there is A, put your 3. Where there is B, put your 2. Where there is C, put your 5. And calculate them the way they are. Whatever answer you're going to find, I think it's given for 144. That's how we find binary operations. Any questions so far? We end here. I'm tired. Any question? Hello? Oh, you can solve as many questions as you can now. All the best in your quizzes. Let me upload the video right now. You can leave the class.
All right, thank you.
All right.